Welcome to Episode 64, Maintenance, Part 1. Controlled maintenance prevents drift by keeping systems in known, trustworthy states. Without structured maintenance, even strong configurations degrade over time as hardware wears, software evolves, and human shortcuts accumulate. Maintenance ensures that the systems you depend on remain reliable, secure, and consistent with approved baselines. When left unmanaged, every service action becomes a potential source of error or compromise. Controlled maintenance is therefore more than technical upkeep. It is governance applied to physical and digital care. A disciplined process keeps operational change from becoming unintentional change, turning repair into assurance rather than risk. Building on that idea, defining maintenance scope and boundaries is the first safeguard against confusion. Scope identifies what assets, components, or environments are included and where authority ends. Boundaries distinguish between maintenance, modification, and development work. For instance, replacing a failing power supply is maintenance, but redesigning circuitry crosses into engineering. Clear boundaries prevent unintended design changes and ensure accountability. They also determine which controls apply, for example, whether formal change management or reauthorization is required. By establishing scope in writing, teams eliminate ambiguity that leads to mistakes. Everyone involved knows what is permitted, what is out of bounds, and what must trigger higher review. From there, authorized personnel and qualification requirements protect both the system and the people working on it. Only trained individuals should perform maintenance, and their access should match the sensitivity of the equipment. A technician may be authorized to service network switches, but not to handle encryption modules. Qualifications include technical certifications, safety training, and up-to-date background checks where required. Authorization should be time-bound and documented, ensuring temporary contractors or interns cannot extend privileges beyond need. Maintaining this roster of qualified personnel keeps trust visible. The goal is simple. No one touches critical systems without verified competence and explicit approval. Before any wrench is turned or command executed, pre-maintenance approvals and change gates keep actions aligned with risk. Each maintenance task should pass through a documented approval process verifying scope, method, and impact. The gate ensures readiness. Backups exist, dependencies are mapped, and rollback plans are tested. For example, before patching a production database, the team must confirm replication health and maintenance windows with business owners. Approval gates prevent maintenance from becoming uncontrolled experimentation. They transform intention into authorization, balancing urgency with oversight. When this step becomes routine, maintenance ceases to be a surprise event and becomes part of normal, predictable operations. Equally critical is the control of tools, media, and parts used during maintenance. Every tool, from diagnostic software to replacement drives, should be verified as genuine, up-to-date, and free of malware or tampering. Media, such as firmware updates or drivers, must come from trusted sources and maintain cryptographic integrity. Spare parts require chain of custody records to confirm authenticity. For instance, a replacement network card should arrive sealed, serialized, and logged before installation. Controlling these inputs ensures that maintenance does not introduce counterfeit or compromised components. A clean supply path is as important as technical skill. Maintenance safety begins with trusted materials. High-risk maintenance activities, such as work on live systems, critical networks, or safety infrastructure, demand direct supervision. Supervisors provide a second set of eyes to confirm procedures, manage communication, and ensure adherence to approved plans. This oversight is not about mistrust, it is about redundancy in vigilance. Imagine a data center technician performing hardware swaps while operations continue. One misstep could trigger downtime or data loss. With supervision, checks occurred in real time rather than after damage. Supervisors also document deviations or lessons learned for process improvement. Structured oversight turns experience into control, capturing expertise that protects both mission and maintainers. Maintenance also intersects with safety, electrostatic discharge, ESD, and handling standards. Safety procedures protect personnel, while ESD controls protect sensitive components from invisible damage. Every workstation should include grounding equipment, protective gear, and hazard signage appropriate to the environment. Proper handling covers labeling, lifting, and environmental considerations like humidity or temperature limits. For example, replacing memory modules without grounding can introduce latent faults that manifest weeks later. Adherence to handling standards prevents subtle degradation that eludes testing but undermines reliability. Safety discipline reinforces the same values as security control, consistency, and respect for process. Configuration capture before work begins ensures that the pre-maintenance state is known and recoverable. This may involve recording system settings, network maps, firmware versions, or baseline hashes. If maintenance alters performance or causes instability, captured configurations allow rollback and forensic comparison. For instance, before updating a router, export its configuration file and note interface statistics. Capturing this data protects continuity and speeds troubleshooting. It also provides evidence for auditors that changes were intentional and reversible. In complex environments, configuration capture is the anchor that keeps every maintenance event tethered to a verified baseline. Protecting data during service events safeguards confidentiality and integrity when systems are vulnerable. Maintenance often requires elevated privileges, diagnostic access, or temporary file transfers. Without controls, sensitive data could be exposed. Measures include using sanitized service accounts, encrypting portable drives, and monitoring administrative sessions. Vendors performing remote maintenance must use secure channels under supervision. For example, a technician troubleshooting storage arrays should connect through approved remote access with multi-factor authentication and logging enabled. Protecting data during maintenance prevents the paradox where fixing one issue creates another. Temporary risk demands permanent discipline in access handling. After work completes, post-maintenance validation and checks confirm that systems function correctly and securely. Validation means testing system performance, reviewing logs, and verifying that controls remain effective. A checklist approach helps. Confirm service status, review error messages, test backup integrity, and ensure monitoring alerts reset. If any deviation appears, rollback or follow-up actions must occur before declaring success. This verification step distinguishes professional maintenance from casual tinkering. Without validation, silence may hide failure. Thorough checks provide confidence that the maintenance achieved its goal without collateral impact. They transform work done into assurance gained. Return to service criteria and formal sign-off close the maintenance loop. Systems should not resume normal operations until all validation steps are complete and an authorized official signs the release. Sign-off indicates that testing met defined standards and that risk is acceptable. For example, a lead engineer may approve the restored operation of a patched firewall after confirming network throughput and rule integrity. Sign-off is both accountability and certification. It records responsibility for the decision to resume service. This closure step also provides auditors with a clear boundary. Before sign-off, work is in progress. After sign-off, accountability returns to operations. Maintenance documentation must include records, timestamps, and traceability details for every action. These logs should show who performed the work, what was done, when it occurred, and what evidence supports success. Timestamps ensure sequence clarity. Traceability links maintenance events to corresponding requests or approvals. For example, a line in the record might reference Task ID 127, approved by Change Manager 45, completed 1432 UTC. These details form the audit trail, proving that maintenance was controlled, authorized, and verified. Good documentation not only satisfies compliance, but also accelerates root cause analysis when future issues arise. Traceability keeps history honest. Finally, third-party maintenance oversight extends control to external providers. Outsourced technicians must follow the same approval, safety, and documentation rules as internal staff. Organizations should verify provider qualifications, review service reports, and retain copies of evidence. For instance, if a vendor replaces disk arrays, their report should include serial numbers, firmware versions, and validation results. Oversight does not end when responsibility is delegated. It intensifies because trust now spans organizational boundaries. By holding third parties to internal standards, organizations preserve continuity of assurance. The system remains protected even when maintenance crosses hands. In closing, disciplined and auditable maintenance practice ensures that operational health never undermines security. Every step, Planning, authorization, execution, validation, and documentation protects against drift and guarantees traceability. Controlled maintenance transforms what could be chaos into predictable, accountable care. When every action leaves a clear trail of intent and verification, maintenance stops being a quiet risk and becomes a visible sign of maturity. In that discipline lies the true measure of reliability, systems that not only work well but stay worthy of trust over time. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.